Okay, so what we're going to do is look at an expected value problem with a bit of a twist. This time we don't know the values of the outcomes necessarily, or I should say we don't know the values of all the outcomes. But we want to find the value of the outcome if we know that we have an expected value in mind already. So here's what one of those might look like. We have a store with an appliance that has replacement cost of $900 that fails within 2 years 0.5% of the time. So I'm thinking that those numbers are going to be somewhat important to us here in a moment. They want to offer a 2-year warranty on this appliance and want to set the price of the warranty so that they can expect to get $30 back per warranty. So remember in the previous example, we charged $36, I believe it was, for warranty, and we expected to get a little bit less. So here, we're kind of reversing it. We want to make sure we get $30 per warranty. How high should we set the price? So we don't know. So I'm just going to say, X is the price of the warranty. So we still have two outcomes. The appliance is okay, and the appliance fails. Now we know that the appliance fails 0.5% of the time, so that's 0.005. And we know the appliance is okay 0.995% of the time, or 0.995 of the time, 99.5% of the time. So what are the outcomes when each of these happens? Well, if the expected value, or rather, if the value of the warranty is what they receive if the appliance is okay, in other words, they don't lose anything, that's just going to be X. Now, if the appliance fails, they still get the money from the warranty, so that's still X, but then they lose the replacement cost of the item, of the appliance, which is $900. So what we have here is expected value, just setting up the equation the way we did before, is equal to the probability of one outcome times the outcome. So algebra is going to come into play here, plus the probability of the other outcome times the value of the other outcome. So since we know the expected value is supposed to be 30, we now have an equation to solve. So we'll just go through our algebraic process here. We'll collect like terms and the like. So we need the distributive property here. The 0.005 gets distributed to each term. And maybe a little calculator help here. Whoop, drop my X. Now 0.005 times 900, last time I checked, I believe is 4.5. In fact, let's just double check that because I'm just not too confident for some reason. Yes, that is 4.5. Great. So then what I'm going to do is I'm going to combine these terms, but if you notice, 0.995 plus 0.005 is 1, so that's just going to be X, minus 4.5. And this equation just got a whole lot easier. We add 4.5 to both sides, and that's going to be the price of the warranty. So now you have a little bit of a sense of where these prices for these protection plans come from. They figure out, they have an idea what they want from each one, and then they backtrack. So $34.50 is the answer to that question. So next time you go to a store and buy an appliance that's worth about $900, you might think about how much you're paying for that protection plan, and if it's about $34.50, now you have a sense of how often that appliance might fail. So I hope this was informative for you, and I thank you for watching, and take care.